Hey there, folks. Going to just continue these notes. Okay, hold on. Give me a minute here. Going to get this started properly. And okay, we're on page 15, just continuing along. We said in this new notation, we can write a neutron with a mass of 1 and a charge of 0 because neutrons are neutral and they have a mass of 1U, which stands for atomic mass unit. Okay, protons. We said a proton is just a hydrogen nuclei. One, it has a mass of 1 because it's one proton. It has a charge of 1 because it's positive 1. We also could write it this way: mass of 1, charge of 1. It's positive. It has a mass of 1 unit. And again, this number up here we now think of as the mass. The number down here we think of as the charge. And what I'd like you to do is, if this isn't in your notes, draw what this is this is a nuclei. These are a bunch of protons and neutrons, a whole bunch of protons and neutrons stuck together. And all I want to say here is that a nucleus, okay, a nucleus will emit radiation until it becomes stable. So, and I guess I should add here, an unstable nucleus, okay? This only happens with an unstable nucleus. An unstable nucleus will emit radiation until it becomes stable, okay? So we might have an alpha particle that gets emitted, and then we might have a beta particle that gets emitted, and then we might have a positron that gets emitted. We might have some gamma radiation that gets emitted. Every unstable nucleus will emit certain radiation, certain particles. And there, you have another chart in your reference tables that's going to tell you about, well, what emits what, okay? All right, flip back to page 12 for a minute. We're going to talk a little bit about the energy and the penetrating power of these different nuclei. Okay, so this one right here that's made of 2 protons and 2 neutrons, oh, I see, that is our alpha particle. And we'll just draw this like it's a helium nuclei, mass of 4, charge of 2. These guys are kind of big and clumsy. So notice they can be stopped by paper, okay? A helium nuclei is big and clumsy. It can be stopped by paper. What's a little stronger and more energetic? A beta particle, which is the same thing as an electron, okay, with a mass of 0, charge of -1. Beta particles are pretty energetic. They can go right through paper, but they are stopped by aluminum. Okay, so right here we'll say paper stops alpha, aluminum stops beta particles. Okay. Now, what's more energetic? Gamma radiation. Gamma radiation with 0 mass and 0 charge is very, very energetic. Okay, it can go through paper. It can go through aluminum. Some of it can even go through lead. Okay, and what it is stopped by is concrete. Okay, so concrete, what lead stops some gamma radiation. That's why when you go to the dentist, they put a lead vest on you. That pretty much basically stops the kind of radiation that they're using for the x-rays, okay? And concrete will stops most gamma radiation, okay? So this little diagram tells you what stops what. Helium nuclei, big and clumsy. Gamma radiation, very, very, very strong. In terms of the charge of these particles, here we've got a little box with a radioactive sample in it, and it's shielded on all sides, except here it can let particles and radiation come out the front. And we have a positively charged plate and a negatively charged plate. Well, what's going to do what? Okay, gamma radiation, because it has no charge, is going to go right down the middle. It's not going to be attracted to the positive or the negative. But since opposites attract, our electrons, okay, which have a -1 charge, they are going to be attracted towards the positive. They could also be written as beta particles. What's going to be attracted towards the negative? Our alpha particles, okay, which they could also be written as a helium nuclei, okay, they have a +2 charge, remember? So they're going to be attracted to a negatively charged plate, okay? So this is a negatively charged plate. This is a positively charged plate. So again, these particles, if we shoot them in a beam, negative ones are attracted towards a positive ones are attracted towards a negative, the gamma go right through the middle. Okay, and I'm going to pause right there,